So welcome to everyone to my YouTube channel. So in this lecture, I will teach about the metal carbene and carbines complex with the metal carbon double bond and triple bond. So carbene, that is a common the formula Cr2 are the species which are highly reactive and rarely stable in the free state. So generally there are two types of carbene. One is the singlet carbene where two electrons in the opposite direction, and one is the triplet carbene with the two electrons in the same spin. So singlet carbenes have a pair of electrons and a sp2 hybrid structure. Triplet carbene have two unpaired electrons. So they may possess either sp2 hybrid or linear sp hybrid structure. So carbene as the ligand in organometallic chemistry as can be broadly classified under two categories. One is the Fischer carbene, another is the Schoch carbene. So compound with metal carbon double bonds are first discovered in 1964 by E.O. Fischer. These compounds are type of MC5 double bond CR over dash, so where M equal to chromium molybdenum tungsten, and they are the formally derived from the coordination of the carbene Cr2 to a metal center. They have been named carbene complex or previously as a Fischer carbene complex. The metal is in the low oxidation state, and the bonding of the carbene is similar to that of the CO. So complex with M double bond C having the highly oxidized metal center are subsequently prepared by the Richard Schoch. They are the called Schoch carbene complex or metal alkyne complex. For example, Cp star, Cp2, CH3 tantalum double bond CH2. So first I'll discuss about the synthesis of the Schoch carbene. So methylation of lithium salt can also be brought about by the reagents such as methyl iodide. These are the most widely applied method for preparation of Fischer carbene. So here, with MO6, the alkyl lithium salt will react to form this intermediate. So then since the carbene electron deficient in undergo nucleophilic attack, if Cr is replaced by O, the following reaction, the interestingly similarity, the ammonolysis of an ester to amide is observed. So here Cr react with this amine to form this intermediate. Upon the ethanolysis is formed this carbene complex. So one can realize Fischer carbene from electron-rich olefins or by addition of alcohols or amines to isocyanide complex. So here the addition of the alcohol in this isocyanide complex gives this Fischer carbene. So unlike the electron-rich noble metals, the early transition metal undergo alpha H abstraction to reduce the steric crowding, and from alkadine metal complex, one can make TaMe5 by the methylation of TaCl2 with the MELI. But as the steric pile of the aryl group increases, it becomes more difficult to accommodate the 5 alkyl group around the metal. So the alpha hydrogen abstraction can be also be initiated by strong light PME5, resulting in carbene complex in high oxidation state. These have been known as the alkadine by the salts. So TaCl5 is equal to 1.5 equivalent in alkyl change to form this intermediate. Then it reacts with the lithium, alkyl lithium to form this intermediate. From this we can obtain the Schoch carbene. Such reactions are quite facile with the tantalum. The methyl group can even be deconjugated to give methylene complex with a strong base such as sodium methoxide. The properties and the chemical behavior of Schoch and Fischer carbene are substantially different because it is different in the nature of metal carbon carbene bonding. So that means the chemical properties of fissile and soft carbene are different. So in this figure, a metal is soft carbene electrophilic and is stabilized by electron donating ligand as well as the back bonding from the pure body of the electron carbon atom. This results in a strong metal ligand bond. The overall bonding in the complex leaves carbon atom electron rich. So main difference between this soft carbene and fissile carbene is that the soft carbene in the fissile carbene the carbon is electron deficient, which stabilized by the heteroatom or the phenyl group attacked by the nucleus. And metal in the fissile carbene the metal is in the low oxidation state, electron rich and attacked by the electrophile and stabilized by the electronegative ligand. Here the metal C carbon bond is relatively weak and low rotational barrier. But in case of soft carbene, the carbon is electron rich and destabilized by the heteroatom groups attacked by the electrophile. And metal in the high oxidation state, the electron deficient attacked by the nucleophiles and stabilized by the electron donating ligand. So here for soft carbene, the metal carbon bond is relatively strong in the large rotation barrier. So fissile carbene, on the other hand, have nearly opposite property. The metal is electron rich. The part of because coordination an electron pair of the carbene carbon atoms and CO ligand in competition with the metal d electron occur between the electron withdrawing ligand like CO and the empty p orbital of carbon. Thus, in turn, is stabilized by the overlap with the electron pairs of the heteroatom substituted. The resulting C double bond N multiple bond is weakened and is a low barrier of rotation. So many of the chemical properties of fissile carbene are like the ester like nucleophilic substitution take place by the tetrahedral intermediate. Also alpha hydrogen atom, for example, this carbene has ancient acidity. The fissile carbene can be described by the following resonance form. The relative contribution of the individual form depends on the partner properties of MJ are at the carbon atom. So here the unit structure. So that means here negative charge on the metal plus of the metal, which can go this way or via this way. So effect of this resonance structure is reflected in the bond distance of the fissile carbene as observed in the extension structure of CO5, CR, CO80, CN-negative. The CR-CO bond distance are observed the range of 2 to 2.2 Armstrong, while the CO-CN bond distance are 1.35 and 1.33 respectively. These are the slightly shorter than the corresponding single bond distance. The conclusive proof of the partial double bond character of the C heteroatom bond is obtained from the NMR spectral studies. For example, the fissile type methoxymethyl carbene complex. So, for example, fissile type methoxymethyl carbene complex adopts the trans configuration in the solid state, which both cis and trans isomers are present in the solution at -50 with hemorrhage 4-methyl peaks in the proton NMR. So, on the bridging to the room temperature, a pairized collapse takes place, leading to the 2 peaks as a result of reduction CO bond. Similarly, observations are also seen in the amino substituted fissile carbene. So this is the structure of the free carbene, a singlet carbene where 2 electrons are in the on p sp2 orbital in the paired electron, and the free carbene is a triplet carbene where the 2 electrons in the on sp2 orbital or p orbital. So in the fissile carbene, here the pair of electrons donated to the metal complex and back donation from the metal field d orbital to FTP orbital, and here the partial double bond between this sp2 orbital and this p orbital. So partially similarity observed between the singlet carbene and fissile carbene as well as the triplet carbene and the soft carbene. So the bonding difference between fissile and soft carbene are be described in this follows. So in the fissile carbene, donation of electron from the carbon to metal dominates with the sum amount of the back donation to the carbon sphere orbital, leaving the carbon atom with a slightly positive charge. But in case of soft carbene, two covalent bonds are between this metal and carbon, both of them polarized toward the carbon, giving a slightly negative charge. The CH acidity of the methyl group bound to the Fischer carbene is constantly enhanced as carbene can stabilize the carbanion from upon deprotonation. So this is reflected in reaction such carbene complex with alkyl lithium reagent. So here the carbene is slightly Fischer carbene slightly electron deficient. So here this CH is slightly acidic that upon deprotonation the negative charge is stabilized. The this structure. So electrophilic versus necrophilic nature of the two different kind of carbene is negated in the following reaction. So this is the soft carbene. So here it is the carbon is a electrophilic in nature, a necrophilic in nature. So electrophilic attack will form this attack, and in case of soft carbene, Fischer carbene, the carbon is a in electrophilic in nature. So here the necrophilic attack is obtained to form this intermediate where the upon elimination of HCl, this carbon this product is formed. So reaction shown by the soft carbene with the ALME3 is similar to the phosphorus with the ALME3. The analog initially described Carbene. So now we have discussed about the Carbene. So Carbene reagent is a 4-member titanium Al metal cycle prepared from the Cp2 TiCl2 and AlMe3. The reagent commercially available as a solution in toluene is highly air and moisture sensitive. The pyrophoric and has a Lewis acid character. The main advantage of the Carbene reagent over titanium carbene based reagent is that the reactivity of carbene pieces can be generated and reacted at low temperature. The efficiency of this reagent is shown from the fact that methylation of benzophenone with Carbene reagent give 97% of CH2CH2 with the yield of only 46% using phosphorus like yield. So it methylated a range of compounds, aldehyde, ketones, ester, thiester, amide, some lactones. So however, it is not suitable for methylation of carbonyl compounds such as acid chlorides, anhydride, imides, and the beta lactone. Such reaction led to undesired product, mostly the titanium anodes. So here this is a Carbene reagent. So here react with the CP2 Me6. So give this 4-member metal cycle which is in the equilibrium with this carbene complex. So this carbene reacts with this carbonyl complex from this intermediate. So in the absence of Lewis base such as pyridine or THF, the reactivity of Carbene reagent with ester is sluggish. But in presence of such base, the reactivity range of the possible substrate increase considerably. This property has been made use for the selective methylation of aldehydes and ketones in the presence of ester and amide groups. The next one is the Graf reagent. The variation of the Carbene reagent had been prepared by the graphs which involve the metal cycle generation from the Carbene reagent. So that this compound is relatively more air stable than the Carbene reagent. The transformation reaction does not require any phase. When this metal cycle is heated, the reactive carbon is generated. These reagents can relatively less utilized for the organic reaction when compared to other two. And another one is the petasis reagent. The petasis reagent is dimethyl titrazine. So here CP TiMe2 is a petasis reagent which utility is precursor for generating CP TiMe2 as first shown by the petasis and co-worker by heating the reagent in THF or toluene at 60 to 70 degrees C with this carbonyl compound. The CP TiMe2 is easily prepared from the CP TiCl2 and MELI and MEMGBr. The compound is relatively stable to air and moisture, can be more easily handled than Carbene reagent. So its reaction can also be promoted by microwave irradiation. The methylation of the benzophenone with the petasis reagent give 90% yield of this product, and is an added advantage of this reagent is recyclability. The dimeric titrazine based side product can be converted to CP TiCl2 by HCl or THF in toluene. In the titrazine, methylidine is generated by heated the alpha elimination, which rapidly reacts with the carbonyl compound. So this is the metasis reagent. It is prepared by sequester TiCl2 with the MgLi or MELI, and upon that THF react with this, give this stable agent. Upon reaction with the carbonyl compound, we give this methylated product. The popularity of the metasis reagent over the other titanosin based reagent is also due to the fact that the reaction conditions are non-basic, unlike the table reagent, no Lewis acid is involved. Therefore, the epimerization of Kylite center is avoided and a wide range of functional group is tolerated. The reaction is the carbonyl are also clean and titanium based side product is easily removed by precipitation and filtration. The acid anhydride and thioaldehyde and imidite undergo methylation with the metasis reagent while they undergo titanium analyte formation with the table reagent. So methylation of strand 4-member beta-lactam proceed with action chemoselectivity with the metasis reagent while unsuccessful with the table reagent. This is how the figure shows below how range of substitution on which the methylation with metasis reagent has been demonstrated and which do not take place with the Betic reagent. And an added advantage of metasis reagent is that its scope can be extended beyond the simple methylation and range of dialkyl titanosin can be made and used for the alkyl dehydration reaction. Mu variation of reagent that can be generated with the CST institute from being discovered. Reaction is with the mixed reagent has been found to be quite useful for methylation with the register with the room temperature under micro conditions. So, removal of the metal component of a carbene by oxidation or reduction. The metal component in a carbene can be removed in such a way that the carbene carbon can be reduced or oxidized. So, carbene react with the LiLH4. So, from this C6H5, CH2, OCH3, or with the reaction with TMSO to form this intermediate. And carbene that are in, so there are two types of carbene, that are fissile carbene and shock carbene. The carbene that are intermediate, now discuss about the carbene that are intermediate between the fissile and shock carbene. There are also examples of the carbene which have the properties intermediate between that of the fissile and shock type carbene. So one of the well studied example is the osmium complex. The synthesis of this complex is this way. So it follows this carbene complex. The Grab's fast generation catalyst is also synthesized using carbene precursor. This compound as well as the second generation catalyst have the properties intermediate between shock and fissile carbene as mentioned by the Grab's himself. So now I will discuss about the use of the metal carbene complexes. The most important and spectacular application of the metal carbene is the olefin metalysis reaction, for which Robert Graf and Richard Schock received the Nobel Prize in 2005. Graf in his colleagues has discovered ruthenium catalysts that are effective in the reaction rapidly, cleanly, and completely by means of the olefin metalysis. So what is noteworthy about the new catalysts is that they are stable in air, will tolerate water, will operate at an elevated temperature. The extra stability. So olefin metathesis is an exchange reaction of two olefinic bonds which result in the two new olefin, one of which is like to be the ethylene gas and thereby easily removed. When the originally two double bonds of the reactant are two opposite ends of the chain of the carbon, their reaction might be exclusively from polymer, which can often happen, but they might also interact with each other to produce ring compound. So the main types of reaction which are the catalyzed by shock and gas catalysis is one is the cross metalysis, second one is the ring closing metalysis, third one is the ring opening metalysis, fourth one is the ring opening metalysis by polymerization, acyclic time metalysis by polymerization, and sixth one is the enine metalysis. So now I will discuss is the metal carbine. So metal carbine complex of the metal carbon triple bond are classified under fissile and the shock types. So EO fissile accidentally prepared the first M triple bond compound in 1973. He called this carbene alkyne. which refers to the chemistry triple bond, the synthesis of metal carbide complex. So an attempt the reaction to a replace of OMe groups of a Fischer carbene by the halogen using the boron trihalide did not yield the halide substituted carbene instead of result in the first Fischer carbide complex. So Fischer carbene reacted with this Fischer carbene with the BX3 to form this Fischer carbide complex. So early transition metal merchant were first prepared by the Schott in 1978 by alpha deprotonation of alkadine. These are the names the alkadines by Schott. While there are some difference between these two compounds, they are treated basically at the same. Thus, one can simply treat it with carbide, and alkadines are a anion and that's 6 electron floating ligand. They are the very strong donor as might be expected from the relatively low electron use of carbon and -3 formal charge. So this is the preparation method of this Schott alkadine Schott carbine. So it reacts with the DMB to form this Schott carbine. The MCO bond distance of the carbine is considerably shorter than the analogous single or double bond. The MCR bond in the axis are also linear and close to linear. A remarkable excess structure, one of the subcompound that contains the tungsten C single bond and this tungsten C double bond and tungsten C triple bond in shown below. It is beautifully shaped the dramatic and acid progress shortening the MC bond and as the bond rod is decreased. So similar to the singlet and triplet carbenes in the bonding model, the three carbine is considered as a doublet for the Fischer type and quartet for the soft type. The doublet carbon donates 2 electrons through its sp orbital hardware orbital and also form an extra covalent bond between the M and C, and one of the p orbital is carbon available for receive the declination from the metal. The quartet carbon from 3 covalent bond via metal 3 via 3 unpaired electrons. So here Fischer carbine is a doublet type. Here the electron donation from these two metal empty orbital and here the electron back donation from empty p orbital and a partial covalent bond between things. And for the soft carbide, that 3 covalent bond formed between the overlap between the p orbital and the p orbital of the carbon. So now I will discuss the reaction of metal carbide complex. So two well-known reaction of the metal carbide are substitution and alkyne metathesis. The strong trans-directing effect of the carbine ligand helps in the substitution of the group trans to it. The carbonyl groups can also be displaced with the Cp star Cp minus. The metathesis reaction of alkynes can be carried out under nil condition in the presence of tungsten alkadine complex with the formation of metal cyclobutadiene as the intermediate, and the reaction can also be applied the ring closing metathesis to alkyne coupled together with the areas of bradyl alkyne. So here the alkadine reacts with the Cp minus to form this complex, and here this alkene react with this alkadine complex to form this ring closing reaction and from this alkene complex. So now I will discuss about some problem. So there are two carbene complex. So given below or actual figure, two well-known Rosina carbene complex. So between this first one, which one of the carbene moieties in each complex take part in the catalytic activity? So here between these two complex, there in both complex there are two types of carbene. One is the intersected carbene, and this is the soft type carbene, and this is also soft type carbene. This is the intersected carbene. So with these two moiety which take part in the catalytic reaction, the intersected NH moiety will not take part in the catalytic reaction. The next one is the which one of the metal carbon bond is the longer in each complex. So here the bond of the NHC and the N heterocycle is the longer since it is a Fischer type carbene. So in the both case, the this metal CO bond length is be longer. So classify the metal carbene as a each fissure short or between this. So here this NHC ligand, this is this NHC carbene complex. So it is a fissure type complex. So this moiety is a fissure type carbene complex, and this is considered as a fissure type in the presence due to the presence of the phenyl ring. So using the next one is the using the given carbonic, the stretching frequency compared to the electronic properties of the carbene with the carbide. So here this is the carbene, this is the carbide. So here for the carbine case, the CO stretching frequency is lower. So that means for the carbine case, the metal has more electron density. So here the metal CO back donation is more pronounced. So that's why the CO stretching frequency is lower. So that means the carbide is more electron donating ligand compared to the carbene. So next one, starting with this CrCO6 or CrCO6 with the minimum number of steps to make the following carbene complex. So to make this carbene complex, so CrCO6 first react with the ETLI followed by reaction with the MEI will result the formation of this carbene complex, and reaction with this CrCN6 on treatment with the aniline directly is this carbene complex. So this one is the reaction you got the reaction between this with the ETLI and the MEI, and this is directly with the aniline to give this complex. Next one is the although the definition of the fissure carbene says that the carbene carbon should be bound at least one metal atom. Many metal carbene complex with the metal in the low oxidation state was having a phenyl group bound to the carbon also. Justify your answer. So the reason is that the electron of the phenyl group can delocalize on the system similar to the lone pair of the heteroatom. So that's why the phenyl group attached to the carbene is considered as a fissure carbene. So next question is classify the following carbenes as a fissure carbene, soft carbene, or between these. So A is a fissure carbene complex. Here the heteroatom is present and metal is the low oxidation state, and B also as a fissure carbene complex. Here also the metal is a low oxidation state and heteroatom present. And C is a soft type complex. Here the metal in high oxidation state, and D also is a soft carbene complex. Soft carbene, here also metal is a high oxidation state, and E is between these two. It may be soft or it may be fissure. So indicate whether a statement given below describe a fissure carbene or soft carbene or neither. So it behaves like a phosphorus yield in Summit's reaction. So this is soft carbene statement. The carbene carbon is a nucleophilic in nature. So this is also soft carbene. Soft carbene carbon is the nucleophilic in nature. It is synthesized for metal carbonyl precursor. So this is for fissure carbene. It catalyzed for cyclotrimerization reaction. This is for NAR. The metal atom is relatively electron rich. So that means it is fissure carbene. The Graf's fast station catalyst is a typical example for this. This is NAR. The metal carbon bond has a relatively low rotation barrier. This is fissure carbene. It quite often does not obey 8 electron rule. That is soft carbene. So next question is in the room temperature, one night spectrum of the CO5 CrCO is a so single resonance of the methyl proton. However, when the temperature is lower, the peaks first broaden and then split into two peaks. Explain the observation. So when the temperature is lower, rotation between the CO bond hindered. So the CO bond leading to a mixture of cis and trans structure. Hence, for this low temperature, due to the rotation barrier, there are two peaks at low temperature for this methyl group. So predict the possible structure for the purpose reaction. So here upon hitting this, so CO all 5 MO double 1 N plus methanol. This product is formed upon heating with this. So predict the following reaction. So in this case, this is the table reagent. So upon react with this, so here alkylation is occurred. So here is here CH2 and here also CH2. Same case. So here only this CH2 is alkylated, and here this CH2 is alkylated. So CrCO6 will react with this, so it form CO whole 5 Cr double bond OET N. So write the possible most probable product when the MOC typically is inside a PHLI, then forward strong carbocation reagent. So it reacts with from this carbene intermediate. So from this CO whole 5 MO double 1 C O Me PH. Consider the following. The next question is consider the following structure. Explain why CR bond is longer in two. So here the carbene carbon electron deficit in both cases. So however in the one there is only one heteroatom containing electron donating group, while in two heteroatom based on the electron donating group. So the effect of this phenyl ring seems to be less compared to the heteroatom. So here this has a CrCO bond length is longer for this because here only one heteroatom. So here two heteroatom. So here the black electron donation to go. So this that's why this CrCO bond length is more for this due to the more electron donation to the heteroatom. So next question is write the possible product in the following reaction. When the reaction is there, so that will form CO whole 5 Cr double bond C O R H and PH O M E is formed. And the reaction given next question, the reaction of the given iridium complex of methyl ether has to do the formation of stable cationic carbene complex along with the release of methane gas. So write the product. So here product is the iridium Cp Me3 P double bond H O Et. So thank you.